Hi, welcome to the video solution for past paper. This is Edexcel IAL Mathematics, paper M1, January 2020, the second video of this paper. So let's start. Question number 5. A car travels at a constant speed of 40 meter per second in a straight line along a horizontal race track. At t equal to 0, the car passes a motorcyclist who is at rest. The motorcyclist immediately sets off to catch up with the car. The motorcyclist accelerates at 4 meter per second for 15 seconds and then accelerate at 1 meter per second square for a further t second until he catches up with the car. Sketch on the same axis the speed time graph for the motion of the car and the speed time graph for the motion of the motorcyclist for time t equal to 0 to the instant when the motorcyclist catches up with the car. So the speed time graph, we have a y-axis and x-axis. We take a speed on y-axis in a meter per second and time on x-axis, which will be in second. And then because the car is traveling at a constant speed from the beginning, so you can say that you have a speed of car. Let's suppose this is 40. This is speed of car till here, and you must mark here 40 meter per second. Okay, and then motorcyclist is starting now because motorcycle was at rest in the beginning, you see here. So first you need to find what will be the velocity of the motorcyclist after 15 seconds. Initial velocity is 0 and acceleration is 4. So you can use v is equal to u plus at, and then you say that 0 plus 4 times 15. 4 times 15. So you say that v would be equal to 60 meter second inverse. That means for till 60 meter per second motorcyclist is accelerating, so you can sketch for something like this. So this is 40 here, this is 40 and 50 and 60. So still here I was just taking something like this, and you can mark here this number as 60, and then it's accelerate at the rate of 1 meter per second. So acceleration is decreasing, so continuously accelerating but with the less rate till time t. So you can extend the graph with the less steep ones, something like this, until catches up the car, something like this. So you can mark this final velocity when it is accelerating with 1 meter per second, and you can calculate this velocity, because you know that for that interval the initial velocity will be 60 and acceleration will be m. So final velocity at that point, this velocity will be equal to v is equal to u plus at, and u is 60 plus 80. A is it's just 1 into t. So this is the final velocity, 60 plus 80, 60 plus t. And then this time you can mark here 15, and this time you can mark 15 plus t, because this is t for further t second. This is the sketch of the motion. At instant when t is equal to t1 seconds, The car and the motorcyclist are moving at the same speed. Find t1. So you know that at time t1 they are moving with the same speed. So the final velocity v is equal to, so you know that for motorcyclist, final velocity of motorcyclist Vm in time t1 will be equal to 0 plus 4 into t1. That means velocity of the motorcyclist Vm would be 4t1, and then they are moving with the same speed. So 4t1 would be equal to 40, because car is moving with the constant velocity. So t1 would be equal to 40 divided by 4, 10 seconds. Part C, show that t square plus kt minus 300 equal to 0, where k is a constant to be found. The idea of finding this equation, because t is the time which is unknown, capital T, but we know that at 15 plus t at this time, motorcyclist is catching up. That means distance traveled by the motorcyclist and distance traveled by the car will be same, and this is the idea that I'm going to use to form this equation. So first we find distance traveled by the car, and distance traveled by the car, I know that this is the area under distance time graph, or sorry, velocity time graph for the car. So this is the distance for car. So distance of car SC would be equal to, because uniform motion moving with velocity 40 into time taken, so total time taken by the car is 15 plus t. That means you can multiply it with 600 plus 40t. And now distance traveled by the motorcyclist, so SM. You see, for distance traveled by the motorcyclist, so I am dividing for motorcyclists into two paths. This is the triangle here, and then this will be the parallelogram. So area of this triangle and area of the parallelogram will give me the distance. So you say that this total distance traveled by the motorcyclist will be half of area of the triangle, first area of the triangle, so 15 times height. So half of 15 times height of the triangle, which is 60, and then plus area of this trapezium. So area of the trapezium will be equal to half of sum of the parallel side. So parallel side will be 60 and 60 plus t. So 60 plus 60 plus t, this is sum of the parallel side of a trapezium times height. Height is the width, which is t. And you know that SM must be same as SC. Distance, both distance will be same. So you can just equate these and you say 600 plus 40t is equal to, and then you just simplify it with the half, and then 30, it is 450 plus half 120 t, half of 120 plus t here into t, and then you know that the okay, fine, and then you can do 450 minus 600, so it is 150. So 150 plus 40t is equal to, you multiply with half and t with the 120 and the 60, so this is 60t, and half of t square plus half of t square. And then rearrange for this equation, bring everything on the right hand side. So you can say that half of t squared is equal to 60t minus 40t. So it will be plus 20t, and 150 comes here, so minus 150 equal to 0, and you multiply by 2 to get rid of this 2 in denominator. So t square plus 40t minus 300 equal to 0, and now this is the required equation. If you compare t square plus 40t minus 3, so t square plus kt minus 300, that means k is equal to 40. Question number 6. A force F is given by F 10I plus J Newton. Find exact value of magnitude of F. So this is a vector question. You are given a vector in ijk component. Remember, if you are given any vector like vector A and just AI plus A1I or plus A2J, and then you need to find the magnitude. So you use Pythagoras theorem to find the magnitude. So magnitude of A will be equal to A1 square, coefficient of I squared plus coefficient of J squared, square root. That's how you can find the magnitude. So solution A will be magnitude of F. So magnitude of F will be equal to 10 square plus 1 squared. So 10 square plus 1 squared. This is 10. Okay. That means 101 root 101 Newton. This is the magnitude. Part B. Find in degrees the size of the angle between the direction of F and the direction of the vector I plus J. So if you visualize the diagram, F is given 10I plus J. So if you want to, it's a good idea if you draw the diagram. So this is x-axis and this is y-axis, and both are positive, so this is fine. So F is 10I plus J, so 10 is somewhere here and 1 unit above J. So this is your vector F. So remember 10I, 1J, and another vector is I plus J. I plus J will be giving 1 unit I and 1 unit J, so somewhere here, something like this. And then this is your vector I plus J, and we need to find angle between these two vectors. So we need to figure out this angle, which is theta. Clearly this theta is the difference of the angle of vector I plus J and vector 10I plus J. That means suppose this angle is theta 1, and if you can figure out theta 2, this is theta 2 for vector I plus J. So you can know, you know that theta would be equal to theta 2 minus theta 1. That's what I'm doing. Now since we have a vector I plus J 1 unit, so theta 2, since theta 2 must be 45 degree. I'm just giving reason here because tangent theta 2 would be equal to opposite over hypotenuse. Opposite is 1, 1, because tangent theta 1, so tangent inverse 1 will be 45. So that's why theta 2 is equal to 45. Now theta 1 will be equal to tangent inverse opposite over hypotenuse. In this case opposite is 1 unit Opposite over adjacent, sorry, opposite over adjacent. So opposite is 1 divided by adjacent is this much, which is 10 unit. So 1 divided by 10. And then angle will be equal to 5.7 degree. Now theta is theta 2 minus theta 1. So 45 minus 5.7, which is equal to 39.3 degree. Or you can say it is 39 degree. This is the angle between the two vectors. So theta, you found here 39 degree. The result of the force F and the force minus 15I plus AJ, where A is a constant, is parallel to but in opposite direction to a vector 2I minus 3J. Find the value of A. Now two vectors are given parallel. So here's the idea. Suppose a vector A, let's suppose this vector A, AI plus A2J, A1I plus A2J. This is one vector and I'm taking another vector just for your understanding, vector B, B1I plus B2J. If I say these two vectors are parallel, if A parallel to B, this is a symbol for parallel. A is parallel to B. That means you multiply coefficient of I of one vector A1 B2 must be same as A2 B1. So A1 multiplied by the coefficient of J of the second vector, and A2 is multiplied by coefficient of I of the second vector. So these two products should be same. If they are same, then vectors are considered parallel. So first we need to find resultant of F and this vector. So let's call it this F dash. So F dash would be equal to F plus minus 15I plus AJ. So F dash finally will be minus 5I plus A plus 1J. Because vector F is 10 plus J. So 10 minus 15 minus 5I and 1 plus A. So A plus 1J. So this is the resultant of the two vector. And this vector is parallel to 2I minus 3J. That means coefficient of I of the first vector minus 5 is multiplied by coefficient of J of the second vector. So since minus 5 multiplied by minus 3, coefficient of I of the first into coefficient of J of the second. So minus 5 into minus 3 is equal to coefficient of the J of the first times A plus 1 times coefficient of the I of the first, which is 2. And now you see here you have just one equation in terms of A, and then you can figure out value of A from here. So 15 is equal to 2A plus 1. So 2A is equal to 13. A equal to 13 upon 2. This is your answer, value of A. Or you wish you can say it is 6.5. Question number 7. A particle A of mass 4 kg is held at rest on a rough horizontal table. A particle A is attached to one end of a string that passes over a pulley P. The pulley is fixed at the edge of the table. The other end of the string is attached to a particle B of mass 3 kg which hangs freely below P. Okay. The part of the string from A to P is perpendicular to the edge of the table, and A, P, and B all lie in the same vertical plane. The string is modeled as being light and inextensible, and pulley is modeled as being small, smooth, and light. The system is released from the rest with the string taut At the instant of the release, A is 2 meters from the edge of the table and B is 1.4 meter above the horizontal floor as shown in the diagram. So this is the situation, 2 meter you know 2 meter away from the pulley, a particle A, and 1.4 meter high, the particle B, 3 kg and the 4 kg. So this is the situation. B is released, it will be falling down, so A will be moving rightward. It is a rough horizontal table, so we have a friction here. Okay, so after descending with a constant acceleration for 2 seconds, B hits the floor and does not rebound. Show that the acceleration of A before B hits the floor is 0.7 meter per second. So we need to find acceleration of A. Remember, we assume that the string is inextensible or light. That means the string has no weight. This is the meaning of light string. And inextensible means acceleration stays the same throughout the motion. So we need to find acceleration of A, but I am using motion of particle B to figure out acceleration of B, because the acceleration will be same. So B is falling down and covering height of 1.5 meter, and this height I'm going to use to find the acceleration of particle B, which will be same as for A. So we know that S is equal to ut plus half at squared, and then substitute the value. S is total height covered, so 1.4. Initial velocity of the particle B, which is 0, so first term will be 0, plus half A into t square, which is 2 seconds, so 2 square. And now you rearrange for A, or solve this equation for A. Once you solve this equation for A, so A would be equal to 2 times of 1.4. So A would be equal to 2 times of 1.4 divided by 2 squared, and 2 squared is 4. So acceleration will be equal to 0.7 meter second minus 2. This is the acceleration. That's what we need to prove here. State which of the modeling assumption you have used in order to answer the part A. As I said, that we assume that the string is inextensible, so that the acceleration stays the same. So acceleration of particle B and acceleration of particle A are the same. That's what we use. So this is our assumption. Part C, find the magnitude of the resultant force exerted on the pulley by a string. So if you see the situation, for pulley, we have two forces acting on the pulley. For pulley, we have a T acting down here in this direction, and another T acting in this direction. So this is T, two T's acting on the pulley, and the resultant of this these two tension on the pulley would be in diagonal, exactly, because T are same, so it will be acting in between these two. So this is the resultant force TR that we need to figure out. So for TR, we need to find T. And how do we do that? We are going to consider motion of the particle B, because this particle is accelerating downward and we have acceleration. We know that for particle B, its weight is acting down, which is of course 3g. And for particle B, tension will be acting upward like this. So this is T for particle B, and it is accelerating down. So for part C, for particle B, we know that 3g is greater than T. That means 3g minus T should be equal to resultant force, and resultant force is MA. In this case, 3 is the mass, and we need to find T. So T would be equal to, T goes there, 3a comes here, so 3g minus 3a, and then 3 times of g minus a, so 9.8 minus 0.7. So T would be equal to 27.3 Newton. This is the tension. And now TR will be resultant of two T's. This T 27 and this T 27.3. Both are the same. So resultant will be Pythagoras theorem. So TR is 27.3 square plus 27.3 square and root. So TR would be equal to 38.6 Newton, which is rounded off to 39 Newton. This is the magnitude of the resultant force, and since theta is equal to tangent inverse, we need to find the angle. That means we need to find that angle from horizontal or from vertical. It's your choice. And of course, because we know that both forces are equal, so the angle should be 45. But we need to prove here. We need to show theta is equal to tangent inverse t by t, or 27.3 divided by 27.3, which is equal to 1. That means 45 degree. This is the angle. Okay. The coefficient of friction between A and the table is mu. Find the value of mu. Now we consider motion of the particle A, which it will be going rightward. So for D, we know that for particle A, we have a friction acting leftward, F, and for particle A, because it is accelerating rightward with the 0.7 because of the tension force. So for A, tension will be acting rightward. And in this case, A is accelerating rightward. That means T is greater than F. So you can say that T minus F should be equal to the net force causing acceleration, and net force is 4A. And T we have already found. What do we need to find? We need to find mu. Okay, so T we have already found. So send F on the other side, because F is equal, or you can do T is equal, T minus mu R is equal to 4A, or you can say T is T minus mu, and R is the contact force. So this is the contact force R, and this contact force R will be equal to the weight 4G, because we don't have motion in a vertical direction. So you replace this R with the 4G. So if mu into 4G is equal to 4A, and then you have everything. You just make mu as a subject. Okay, you rearrange this equation because you have T we have already found. So you just rearrange this equation, make mu as a subject. When you do mu as a subject, so your value of mu should be equal to 0.625, or you round it off till 0.63. There is no unit for coefficient of friction, mu. So this is the value of mu. I'm not solving, I'm not doing it, I'm just leaving for you. So pause the video, try to solve it, see if you can get 0.63. Again, as I'm saying that if you need every step, so please let me know in the comments. So this is D. Okay, part E, determine by calculation whether or not A reaches the pulley. So you see what will be happening here. I'm just erasing all these working, but you need to keep these numbers in your minds. Coefficient of friction 0.63, we might need it. In fact, we are going to need it, and the rest of the numbers are given. T equal to 27.3 Newton. So now first you need to understand the motion of particle A, what will happen with A. We know that as when B will be falling down, coming down, A will be moving rightward. When B hits the floor and does not rebound, as the condition is saying, that means at that moment particle A has already covered some distance, which is 1.4. So 1.4 already covered by A, and at that moment particle A will be moving with some velocity. So particle B will be stopped but does not rebound as per assumption, but particle A due to inertia will be keep moving rightward. But when the particle will be keep moving downward, so string will not be taut. So the acceleration after that point, after 1.4 meter, the acceleration will be different. That's what we need to figure out first, that what will be the acceleration of the particle A when a string does not remain taut. So first we already know that the distance of particle A, SA1, I'm just for your understanding, I'm writing it is 1.4. This is 1.4 meter already covered with acceleration of 0.7. And then after that, the particle A will be moving some other acceleration. And now when a string is not taut, so remember, after this point, and you can mention this point, let's say this point is maybe you can take Q. So after Q, which is 1.4 meter, after Q, T will be 0. But it will be moving on the table. So friction is there. That means particle is moving against the friction. After that, particle will be moving only against the friction. So friction is the resultant force that will be causing slowing down of the particle A. So friction is acting on the particles. So you say that friction, which will be in opposite direction, will be resultant force ma, and m is 4 into a. So acceleration will be minus f upon 4, and f is mu r, and mu minus is there. So mu is 0.63, we have already found, and r is mg. So m is 4 into g divided by 4. So 4 gone. So acceleration would be equal to minus 0.63 times 9.8, which will be equal to minus 6.2 meter second minus 2. This is the acceleration due to which the particle A, after covering 1.4 or when B hits, it will be decelerating and slowing down with the rate of minus 6.2. And then second approach is, we have different approaches after that. So we are going to find, okay, if the particle is moving with that acceleration, so how much distance it will cover. So first we find the velocity of the particle at q, because particle was at a at the beginning, particle A was at rest and it is accelerating. It was accelerating at the rate of 0.7. So at point q, after covering 1.4 meter, the particle gain some velocity, and that will be the velocity, final velocity for the first interval. That's what we need to figure out. So how do we do that? We can figure out the velocity by using v is equal to u plus at, because from the first interval. So final velocity v, u will be 0 here, and acceleration is 0.7, and time is 2, which is given here for first interval. So v would be equal to 1.4 meter second inverse. This is the final velocity of the first interval, but this final velocity will be considered as initial velocity for second interval. Initial velocity for second interval. That means now at that point the initial velocity is 1.4, which is this, and it is decelerating with that rate, and it will be slowing down. So we assume that at somewhere the particle stops, suppose here, or maybe here, it depends. So the velocity of the particle when it comes to rest, after that, so the final velocity will be 0, And that's concept I'm going to use to find out a next covered distance. This is S2. So we know that since V square is equal to U square plus 2AS, and V square I'm considering is 0 and U square is 1.4, which was the final velocity of the first interval but initial velocity of the second interval. So 1.4 square plus 2, acceleration is minus 6.2 into S. Now you solve this equation for S, or S2, as I just mentioned in the diagram, the second distance. So S2 you will find as 0.157 meter or 0.16 meter. So total distance of the particle A will be equal to 1.4 plus 0.16, which will be equal to 1.55 meter, meaning 1.6. That means SA is less than 2 meter, because 2 meters is the total distance. So the particle A will stop after 1.6 meter. That means A does not reach the pulley. Thank you very much. I hope you understand, and have a nice time.